All right, kids, the two-pole problem. So these two poles are constructed, they're on either end here, the 6 and the 12. And they are built, correctly. They are sticking vertically up out of the ground, okay? Vertically up out of the ground. So we know that we have right angle here, we have right angle here, and these two ropes are pulled completely tight, and they intersect here, and clearly this is perpendicular as well. How far above the ground are the ropes intersecting? Let's go ahead and call this A, B, C, D, E. Now I hope you realize here that we actually have similar triangles, okay? Because these poles are built straight out of the ground, they're parallel, so we have alternate interior angles there and there. So triangle ABC is similar to triangle DEC. Okay? And obviously, AB corresponds to DE, so sides are in the ratio of 6 to 12, or 1 to 2. Okay. Now realize we have additional similar triangles as well. Okay. And we're going to now apply this to the, well, actually, hold on, I'm getting ahead of myself. So these triangles here kind of look like a lopsided bow tie. They are 1 to 2. Now, I don't know what side BC is. I don't know what side CD is, but I know they're in the ratio of 1 to 2 because they correspond. So x to 2x. Okay. But I also have additional similar triangles, which is what I was getting at a moment ago. I have this triangle here. Whoops. Let's try to get my highlighter going here. This one here is similar to this one here, right? Because they both have this right angle and they have this reflexive angle. So if those are similar, and this is x and that's 2x, that means this hypotenuse is x, this whole hypotenuse is 3x. Okay? So the ratio triangle, if I call this triangle CBF, is similar to triangle DBE. Sides are, what did we say, 1 to 3, right? Because it's x to 3x. Well, this vertical leg, x, is to this vertical leg, 12, 1 to 3. Cross and solve, and you get that height of the intersecting ropes is 4. All right. Now on the back side of this document, whoops, we're going to do the same exact problem, but we're going to do this in general terms. So in other words, it's still two poles, but now this height is A, this height is C, find X. So we still have this situation, just like what I did before, where you have these being parallel, these two triangles being similar for the reasons I gave on the previous page. But now you see, with those two triangles being similar, instead of the ratio being 6 to 12 or 1 to 2, the sides are in the ratio of A to C. Okay. All right. Now I don't know what this measure is, BC or CD, but I know that these two sides have to be in the ratio of to C. So if I call this, give it some multiple, like let's say some fixed value M. So this could be AM and this could be CM. Okay. We don't know what they are, but they have to be in that ratio of A to C. So now let's use the right triangles, and we can set up a proportion, do a little solving here. You see? So, well, let's do the leg. This leg is to that, so x is to c. As this hypotenuse, this little hypotenuse, is to this whole hypotenuse. Remember, that whole hypotenuse would be AM plus CM. And I hope you realize here on the right side that these these m's would just cancel out. And now you can cross multiply. You get x times A plus C equals AC. You're solving for x, so we're going to divide by this quantity. So x equals AC over A plus C, which means the height of the intersecting ropes is always going to be equal to the product of the poles over the sum of the poles. Every single time. That's what we just derived. Kind of cool.